Lesson 3.3 is all about polynomial identities. In this lesson, we'll look at a variety of multiplying and factoring rules for different types of polynomials. An identity simply helps transform one side of an equation to the other. All of the identities in our left-hand column have the rules or the definitions already on the right-hand side. It's kind of nice. We don't have to write out a lot for their definitions. Let's start off by multiplying a square of a sum. And this actually works for sum or difference. You can do it for adding or subtracting. And the rule is this: if you have a parenthesis being squared, remember you have to write it out 2 times. That would be the square of that sum. From here, you'll just FOIL. The example on the right, if you have 3x plus 4y squared, we're not just going to square each part. That doesn't give you the correct result. What we have to do instead is literally write it out 2 times, so just side by side. 3x plus 4y times another 3x plus 4y. When we FOIL, make sure that you multiply the coefficients together and then group the variables accordingly. If I do the first term times the first term, 3 times 3 is 9, x times x is x squared. And then if we multiply 3x times 4y, 3 times 4 is 12, and x times y simply stays that product, xy. If I take 4y times 3x, I get 12 again, and y times x is the same as x times y, so I'm just going to write them in the same order. And then if I take 4y times itself, 4 times 4 is 16, and y times y becomes y squared. To write out our answer, taking a look at matching up like terms, I'm just going to write it from left to right. The 9x squared has no other like terms, so we'll leave that as such. The 2 terms in the middle, notice the variables are identical, and when we add, we're just going to combine their coefficients. 12 plus 12 is 24. The x times y doesn't change. They're done. And then we have our 16y squared, and that is the product for 3x plus 4y squared. Just a lot of foiling. And remember, that can work for addition or subtraction. The rest of our rules are all about factoring. So the next one is called the factoring difference of squares. Now, unlike up above when we can multiply with adding or subtracting, this only works for subtracting. This does not work for addition. So it only works with subtraction. And we've actually used this rule before back in topic 2. If you have a squared minus b squared, meaning a perfect square minus another perfect square, you can split it up into the sum and the product of their square roots. So we have to think about what square roots are, like 4, 9, 16, 25, and so on. Those are examples of numbers that are perfect squares. And any variable that has a multiple of 2, like x squared, x to the 4th, x to the 6th, would all be examples of perfect squares with variables. Let's take a look at the example on the right. We have 25x squared minus 36y squared. 25 is a perfect square, x squared is a perfect square, 36 is a perfect square, and so is y squared. We have a perfect square minus a perfect square. What I recommend you do first is kind of split it up into that a component and the b component. What's actually being squared? In that first term, 25 would be 5 squared, and x squared would be x as a quantity being squared. So if you had 5x squared, you'd square both parts and you'd get that 25x squared. If you do the same thing for 36y squared, the square root of 36 is 6, and then y squared would be the y on the inside. So now that 5x is like your a value, and the 6y is like the b value. And we literally just use this template to factor. I'll just write the 2 parentheses, give myself a little bit of space here. The first factor says a plus b, and you could do the plus and the minus on that right side in either parenthesis. The order of that doesn't really matter. If we do a plus b, that would simply be 5x plus 6y, and then a minus b, 5x minus 6y. And that's all you do to factor the difference of perfect squares. Make sure to always test for a common factor first, just in case something might be able to come out before you separate it into two smaller fractions. Not fractions, into two smaller parentheses. The final set of factoring rules that we'll look at in the video today, factoring sum and difference of cubes. So we notice we have two rules. We have a rule for subtraction and a rule for addition. Now, perfect cubes are obviously different than perfect squares. So let's write out the for perfect cube values from 1 to 10. 1 cubed just means 1 times 1 times 1, and that equals 1, but that's a perfect cube. 2 cubed would be 8. 3 cubed, 3 times, those are 3's right there. 3 times 3 times 3 is 27. 4 cubed would be 64. 5 cubed, now these are going to get kind of big, 125. 6 cubed would be 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And if we go all the way up to 10 cubed, that's 1,000. So all the numbers on that right-hand side are examples of perfect cube values. For variables, it would be any number that's a multiple of 3. Like x cubed would be a perfect cube. X to the 6th power would also be a perfect cube. X to the 9th power. So what we'll have to do is determine what makes a perfect cube and if it follows either of the rules on the right. Let's start off with subtraction. It says a cubed minus b cubed. Notice we don't have 3 parentheses, so it's not a minus b times a minus b times a minus b. Make sure to not think that it's just that quick and easy, because it actually really isn't. You're going to have a small version of a parenthesis and then a trinomial or a version that has 3 terms. So there are only 2 parentheses when you factor perfect cubes. If you know what your a value is and you know what your b value is, you literally just plug it into this template. Let's take a look. The example on the right, we have 8m cubed minus 27. So looking at our list, notice 8 is a perfect cube. Oop, I didn't want it to be a highlighter there, sorry. 8's a perfect cube. M cubed would also be a perfect cube because it's a multiple of 3. And if you look over on that left-hand column, 27 is also a perfect cube. So it looks like we have perfect cube minus perfect cube. We're going to follow this template on the left once we determine what a equals and what b equals. To have that 8m cubed, we need to have something on the inside to the 3rd power. Well, 8 is the same as 2 cubed, so I'm going to write that 2 on the inside. And m to the 3rd power would be the same as m on the inside raised to that 3rd power. So this is what a equals, 2m to the 3rd power. b, 27 is over in that column on the left. 27 is the same as 3 cubed. So 3 is what our b value equals. All right, to split this into a product of smaller parts, so we're going to factor. We're going to do that little parenthesis and then a bigger parenthesis. And I like to make that second parenthesis kind of big because there are a lot of parts that we'll put in there. The first parenthesis is simply a minus b. So a is 2m and b is 3. And it becomes 2m minus 3. It's that second parenthesis that gets a little tricky, so take your time on this. That second parenthesis says a squared. So we're going to take the 2 and the m, and we have to square that. That means we'll have to do a little bit more work in that parenthesis. And then notice it says plus, so we're going to put a plus right here. And then it's a times b. So a times b, that's 2m times 3. Okay, and then we have a plus again. And then it says b squared. So now we're going to take that plus, and then we'll do b squared. B is 3, so we'll have to square the 3. And then that'll simplify that second parenthesis. The first parenthesis doesn't change. We just leave that 2m minus 3. But now for that second parenthesis. If we square 2 and m, 2 squared would be 4, m squared would just stay m squared. And then it's plus. If we multiply 2m times 3, we're just multiplying coefficients, that would be 6m. Plus again. Our last term, 3 squared, that's easy enough, that's 9. And that's factored for that difference of perfect cubes. Here are some things to note. This second parenthesis, even though it looks like you might be able to do something with it, it will never factor, that's an n, wow, hang on, that doesn't look like an n, that would be weird. All right, it will never factor further. Even though it might look like it could, so it never factors further. Make sure to write that down. I know it'll look like you want to separate it more, like the 4m squared and the 9, but it just doesn't work that way. So it's kind of unfortunate. All right, let's try that last rule. Notice in this last rule, when it's addition, a couple of things change, but the main template does stay the same. When we have addition, a perfect square plus a perfect square, instead of a minus b, it just goes a plus b. And in that second parenthesis, the only difference is that subtraction goes in the middle. But otherwise, it's a squared and then ab and then plus b squared. So if it's plus here, it's always minus in that second spot. All right, let's try the example on the right, and then we're done. G cubed plus 64h cubed. Well, anything that's a multiple of 3 is automatically a perfect square. In our list on the left, guess what? 64 is also a perfect square, and so is h squared. We're in good shape to factor this sum of perfect cubes. We want to get our a cubed and our b cubed, and we'll put plus in between. G to the third power would just be g as your a value in that parenthesis. 64 is the same as 4 to the third power, and then h cubed would just be h. So G is in our A location, 4H is in the B location. See if you guys can do this. Can you factor this into the small parenthesis and then the bigger parenthesis and then simplify? Pause the video, give that a shot, and then press play when you think you're done, and we'll see if we have a match. All right, how did you do? When I split it up, I got G plus 4H in the small parenthesis. In the big parenthesis, g squared minus the product of g times 4h plus 4h quantity squared. I ended up with g plus 4h in my first parenthesis times g squared minus 4gh plus 16h squared in that second parenthesis. And remember, that second parenthesis will never factor further. And this is your video lesson for 3.3 Part 1.